Alright, welcome back. So we're having a look at this one here, and it's put really two equations, hasn't it? Sine squared x is equal to cos squared x plus a half. So what's the intersection of these two? There's probably a couple of different ways to do this. The one that springs to mind is the kind of obvious one. So we might do it both methods, y and x. So you get 1 equals x squared plus y squared. Now, if we go for the rearrangement of that, we get 1 equals x is cos plus sine. So what that tells us is that sine squared is equal to 1 minus undo cos squared. So we can insert that in the left hand side, so we get 1 minus cos squared is equal to cos squared plus a half. Now a bit of undo and manipulation. Okay, so adding the half, well, we can add the cos squared. I always tell you people sometimes I just get tempted to let it read. So that is not right step. But cos squared, so if I undo, that side's gone. So 1. So here we get 2 apples. Cos squared plus cos squared is 2 cos squared x plus a half. Okay, so let's think about this a little bit further to make that equal to 0. Want to do that? Yeah, subtract. So 1 minus a half is just a half. 2 cos squared x. So now dividing by 2 both sides. So we're going to get 1/4, that's just the algebra. We don't need to get too fancy with that. Taking the undo at both sides, putting cos x back on this side. Cos x is equal to plus or minus 1 over square root of 4 which is plus or minus half. So we're looking to do 2 solutions. Plus or minus a half. When is x a small positive here? That is those 2 60-degree triangles. When is it a small negative here? So it's all of those solutions. Okay. So for the plus version, x is equal to pi on 3. That's our first one. Then you've got to count around. Get your 1, 2, 3, 4, 5 plots of pi on 3. And for this one over here, the negative x, negative small negative x, we've got 2 lots of pi on 3. and also you count around to 1, 2, 3, 4 lots of pi on 3. So that satisfies, those 4 values satisfy cos x plus or minus a half. And you can put that in, knowing which one you're going for, plus or minus a half, and you get that. Okay. Alright, so it's up to you to check. I'd like to do the count around rather than add and subtract the positive, negatives. You can check it doing that if you want to, but I'm happy not to. Alright, so the other thing we can do is use a double angle formula. And so the double angle formula will give you the same result. Don't ever take your mind away and to say that maths is different. They all should lead to the same place. Okay, so double angle. Now the reason that I'm doing it is because it does come up. If you've never seen it before, it can. So cos squared x so that's one. So for this one, we can just use the U formula. Just an alternative way of doing this. So if U is 2x, we get cos U is equal to negative half. So where do we get a small negative x here? We get a small negative x on the 60 degrees. They're a count, aren't they? So I've got 1, 2, 3, 4. So 60 degrees is pi on 3. We've got 2 lots of pi on 3. And got 2 lots of pi on 3. So got 4 lots of pi on 3. That's why we get small negative x's. For our unit triangle, it's going back to the white sheet every time. Okay, so the x value is a half. Now we also said that u was equal to 2x. So we're going to solve this now for 2x. So 2x is equal to 2 pi on 3. So divide by 2. So x is pi on 3. Further, 2x was equal to 4 pi on 3. Divide by 2. So we get x is equal to 2 pi on 3. Previous one. So this one here, we're working out for minus. So we can repeat that for the half. And we'll get 4.3553. Alright, so that's the same as the option one. Alright, so let's keep going. 2tan x equals 2 squared x. So if we use our Pythagoras, we can do tan squared theta. So again, just on the run, you can do it this way. And by association, okay, if we divide that by cos squared, we'll get 1 over cos squared. Sometimes these things don't seem like, why do we do that? This is 1 now. And sine over cos is rise over run, or tan squared. So we've got a solution for this one here is cos, so it's sec. So we've got sec squared. That's the bit we wanted. 1 plus tan squared. Okay, so we can substitute that in here, and we'll get 2 tan squared x, very nice, is equal to 2 plus, and we better put a bracket in. Do we need to? It's all positive. So tan squared plus 1. I'll use a bracket there for the algebra if it was appearing that there was a minus 1, but there's a plus, so it doesn't change anything. Alright, very good. So if we take away a tan, squared x, what you do to one side, you do to the other, undo. So 2 apples minus an apple will leave you with tan squared x is equal to 2 plus 1 is 3. Now if we take the square root of both sides, we'll get tan x is equal to plus or minus square root of 3. Alright, so in order to work this through, we need to understand when tan is positive. It's not going to be a regular angle, I don't think, but I'll have to check that. It may well be, because it's opposite over adjacent. So it's root 3 over 1. So in actual fact it will be, because if we look at our exact values trig, we get a 60-degree triangle, which is root 3 on 2, half and 1. If we times that by 2, this is in our white sheet, we will get 2 root 3 and 1. So this angle is tan, which is opposite over adjacent. So without even thinking about it, we can say that x, or theta, is equal to 60 degrees, or pi on 3. Now, it's just a question of adding up the plus or minuses. So when is 10 positive? So 10 positive is here, plus y, so that's going to be in it. So that theta will be in it, because theta, or x, therefore x is equal to pi on 3. So that will be in it. So that's one solution. Now, in this case here, we would have a negative x and a positive y. So that would give us a negative. Oh, well, wait a minute, we're looking for both plus and minuses. So in actual fact, it's also going to be in it, which is a count of 2. Okay, so we're going to have to say x is 2 lots. 1, 2. 2 lots of pi on 3. Okay, very good. When is 10 plus or minus? Down here, x is negative and y is negative. So we've got 2. Negatives make a positive, but we're after a positive. So it's also going to be a count. So 1, 2, 3, 4 lots of pi on 3. Okay, and finally, when we come around to the next area here, with our diminishing triangles, we've got a negative y, but a positive x, so that's one of the negatives. So the negatives are here and here, the positives are here and here. So that's also a count. 1, 2, 3, 4, 5. That's 5 lots of pi on 3. So there's our answer solution. Okay, now you can do it other ways if you want to, but exact values trig deserves our attention with some respect, doesn't it? Alright, that'll do us for here. I think that's the last one for this particular set. So it's been a wonderful time. I hope that you understand that I've been fair and tried to help you understand that exact value trigs is going to be a big part of your future in Maths 1, so you need to know it. And the counting around is making it simplified and easier. I mean, you can plus and minus from all the axes if you want to, how they do it in school. But I think just counting around, getting the base one using recognition is a much better way to do it. All right. I hope you've enjoyed your time with me, and good luck with it all. That's the last of the workshop videos. Bye for now.